Hi friends, today topic is stratification. This is part 5 training video of 7QC tool. If didn't watch last 4 video, please see that video for complete understanding of 7QC tools. Let's start. What is stratification? Or definition of stratification. A technique used to divide the data into subcategories or classification to provide useful insight into the problem. 0R stratification is an act of dividing the data based in groups, division, subclass, cause, etc. Stratification is a data analysis technique that involves dividing a dataset into subcategories or classifications based on specific criteria. It is a valuable method for organizing and understanding data, as it allows you to gain insights by examining the data within these subgroups. Next is when to use. When data comes from several sources, such as several shifts, days of the week, lots, suppliers, pieces of equipment, and so on. In combination with check sheet, scatter diagram, control chart, histogram or similar data collection or analysis tools. Next, more detailed explanation of what stratification is and when to use it. Dividing data into subcategories, stratification is essentially the process of breaking down a larger dataset into smaller, more manageable subsets. These subsets, or strata, are created based on a particular characteristic, variable, or factor of interest. The goal is to group data points that share common attributes, making it easier to analyze and draw conclusions. Providing useful insights by dividing the data into these subcategories, you can uncover patterns, trends, and variations that might not be apparent when looking at the data as a whole. This can provide valuable insights into the underlying factors that affect the dataset and help in making informed decisions or identifying areas for improvement. When to use stratification? First, multiple sources of data. Stratification is particularly useful when dealing with data that comes from various sources or is influenced by multiple factors. For example, if you are analyzing the performance of a manufacturing process, you may want to stratify the data based on shifts, days of the week, lots, suppliers, or pieces of equipment. This helps you understand how different factors impact the outcome. Second, combination with data analysis tools. Stratification can be used in combination with various data collection and analysis tools, such as check sheets, scatter diagrams, control charts, histograms, or any other statistical methods. By stratifying the data before applying these tools, you can gain a deeper understanding of the relationships and trends within each stratum. For example, if you are trying to identify the root cause of defects in a production process, you can stratify the data based on different shifts or equipment used. This can help you pinpoint which shifts or equipment are associated with higher defect rates and, in turn, direct your efforts toward improving those specific areas. In summary, stratification is a data analysis technique that involves dividing data into subcategories or strata based on specific criteria. It is a valuable approach for gaining deeper insights, particularly when dealing with complex datasets influenced by multiple factors. By using stratification in combination with other data analysis tools, you can make more informed decisions and take targeted actions to address issues or improve processes. Next, different examples used in different fields. Stratification is a versatile data analysis technique that can be applied in various fields to gain insights, identify patterns, and make informed decisions. Here are some examples of how stratification can be used in different contexts. It is used during manufacturing quality control process. In a manufacturing setting, data can be stratified based on different shifts, production lines, or equipment used. This helps in identifying which specific factors are contributing to defects or variations in product quality. By separating the data into groups, you can pinpoint and address issues more effectively. It is also used during customer segmentation analysis. In marketing, customer data can be stratified based on demographics, behavior, or purchase history. This segmentation helps businesses tailor their marketing strategies to different customer groups. For instance, an e-commerce company can use customer stratification to target promotions to specific customer segments with personalized offers. It is also used during healthcare outcomes. Healthcare data can be stratified by patient age, gender, medical condition, or treatment method. This allows healthcare professionals to analyze the effectiveness of different treatments for specific patient groups. For example, a hospital can use stratification to assess the outcomes of a new treatment for a particular disease based on patient characteristics. It is also used during academic performance analysis. Educational institutions can stratify student performance data based on factors such as grade levels, subjects, and teaching methods. By analyzing student performance within these groups, educators can identify which subjects or teaching techniques may require improvement and implement targeted interventions. It is also used during financial analysis. Financial data can be stratified by industries, company size, or geographical regions. This enables investors and financial analysts to assess the performance of different sectors or companies. For instance, a financial analyst can use stratification to compare the profitability of tech companies in different geographic locations. It is also used during environmental monitoring. Environmental data can be stratified by factors like location, time of year, or pollutant type. This allows scientists and environmental agencies to understand how specific factors affect air or water quality. Stratification can help in formulating policies and measures to address pollution in specific areas. It is also used during employee performance evaluation. Human resources departments can stratify employee performance data based on job roles, departments, or years of service. This helps in identifying high-performing employees, areas that need improvement, and making informed decisions regarding promotions or training initiatives. It is also used during retail inventory management. Retailers can stratify inventory data based on product categories, sales volume, or seasonal demand. This helps optimize inventory levels and product placements. For example, a store can use stratification to ensure that high-demand products are well-stocked during peak seasons. Social science research. Social science research. Researchers in social sciences can stratify survey data based on demographic variables such as age, gender, income, or education level. This allows for a more detailed analysis of the survey responses within specific population subgroups, enabling researchers to draw more accurate conclusions. These are just a few examples of how stratification can be applied in various domains to improve decision-making, problem-solving, and understanding of data. Next, let's discussion about an example. If we don't follow stratification, then all NG or non-conforming products are kept in one place. Yellow color means OK product or good product. And red color means NG or non-conforming product. There are 3 production line. In production line 1 there are 2 OK products and 2 not OK products production done. In production line 2 there are 3 OK products and 1 not OK or NG production done. In line number 3 there are 4 OK products production done. Collect all non-conforming products in one place. But in day-to-day life it is very difficult to do analysis, which line is best or worst. Also difficult to trace the all non-conforming products. If anyone follows stratification tool technique, then the way of life will be different. In the same example, as you know here are 3 production line. As discussed, in production line 1 there 2 OK products and 2 no OK product production done. Keep these 2 NG products in one location. Maybe with proper identification. In production line 2 there is 3 OK products and 1 no OK or NG production done. Keep this NG product in another location nearer to line. In line number 3 there is 4 OK products production done. Though there is no NG product, still you have to define a fixed location for NG product storage location. This is best ways to do analysis. Anyone can clearly say, line 1 worst line as NG, it produces more defective products. And line 3 is best one, as OK products can be manufactured in this line. This is the benefits of stratification tool. Next see another example. It's a product defect analysis by stratification. 5 different size product, which were produced from 2 different machine A and B, in different date and time. Also the product produced from different materials such as E and F, also the machine operators are different, such as Ramesh and Naresh. This type of complex data generally we see in our day-to-day production activity. Possible causes of defects can be analyzed by stratification. Here to machine, 3 different time format, such as AM, PM and night shift. By material E and F, by year experience of operator, same will be stratified. Next we will see third example of stratification. Car purchase survey report, which is a comparison in between capital, city and town. Data also taken gender-wise purchase and also age group-wise purchase. By making such chart anyone can easily analyze. Next is, let's elaborate on how the process of separating data into groups, drawing meaningful inferences, diagnosing and localizing problems, and identifying influencing factors is an integral part of effective data analysis. Separate data into groups. Before you can make sense of a large dataset, it's often necessary to divide it into meaningful groups or subsets. This process of separating data into groups, often referred to as stratification or categorization, helps in simplifying the analysis. For example, if you are analyzing sales data for a retail store, you might stratify the data into groups based on product categories, geographic regions, or customer demographics. This separation allows you to focus on specific aspects of the data and understand variations within each group. Draw meaningful and correct inferences. Once the data is grouped, you can start drawing inferences or conclusions. Analyzing data within each group enables you to make more specific and accurate observations. You can identify trends, patterns, and anomalies that might not be apparent when looking at the data as a whole. These inferences can be related to, for example, which product categories are performing well, which regions are showing growth, or which customer segments are most profitable. This information is valuable for making informed decisions and setting strategic goals. Diagnose and localize problems, cause and effect. One of the primary goals of data analysis is to diagnose and localize problems. By breaking down the data into groups, you can establish a clear relationship between a potential cause and its effect. This is particularly valuable in quality control and process improvement. For instance, if you are experiencing defects in a manufacturing process, separating the data into groups based on variables like machine operators, shifts, or equipment used can help pinpoint where the issues are originating. You can then focus your efforts on addressing these specific problem areas. Identify influencing factors. By analyzing data within each group and studying the relationships, you can identify the influencing factors or variables that have a significant impact on the outcomes. These factors can be either positively or negatively correlated with the desired outcomes. For instance, in a marketing campaign analysis, you might find that certain advertising channels or customer demographics have a more pronounced effect on conversion rates. Identifying these influencing factors allows you to allocate resources more effectively and fine-tune strategies. That means separating data into groups and then drawing meaningful inferences from these groups is essential for effective data analysis. It not only simplifies the data but also helps diagnose and localize problems, establish clear cause and effect relationships, and identify the key influencing factors. This process is fundamental for making informed decisions, improving processes, and optimizing strategies in various fields, from business and healthcare to manufacturing and research. Hope you have already watched part 1, 2 and 3 video of 7QC tool. Thank you.